Okay, so today we're going to do distance, time, and they're going to be sketches. And it's really important to note the difference between a sketch and what we're going to do next, which is a graph. Okay? So when we do a sketch, what are the things we have to worry about? Well, we don't need a ruler. We don't need to put the full name on our sketch, our axes. So here I could say D for distance, T for time, okay? I don't need a ruler even to draw my line. So I could have a line that looks something like that. And that's all I need for a sketch. I don't need a scale. I don't need, if you had a graph, you would have to write distance and then the symbol and then the units. You'd have to have this on graph paper. You would have to have a title, all kinds of things that we don't need for this one. Okay? So, a distance time sketch is going to tell us all kinds of information. The first thing it says, the steeper that graph or sketch, the faster the motion. So if I had a line like this, and this was car A, and I had one here, car B, which car would be moving faster, A or B? A, because that is steeper. Okay, the higher up you go, the steeper that line is. So car A would be going faster. Next one, a horizontal line, and when I'm talking about a horizontal line, that's what I'm talking about. A horizontal line means the object is not changing its position. It is not moving, it is stationary. So on the side here, this axis says position, and if it's horizontal, I am not changing. Time is going by, but I am not changing my position for a horizontal line. A downward sloping line means the object is returning to the start or home. Generally, when we have these, we say this origin, the 0 point, either we call it home or we call it our start position, okay? Because in physics, we tend to give it a name as opposed to those coordinates, 0. So, if it's going back home, my object, it says downward sloping, so it's going to be like that. That would be going back home. Going home. So you're farther away, and here is the home position. Yes, time has passed. It's not at 0, but you're still at home. Okay. Yesterday we talked about slope, and we said the slope of the line is equal to the speed of my object. The slope of the line. Okay, and we did horizontal slopes, we did vertical slopes, and we did lines that were trending up and lines that were trending down. If we have a straight line, which all of these are, it means the speed is going to be constant. Why? Because the slope of your line is going to be equal to speed, and in this case, speed is constant. A curved line. Well, we haven't really looked at a curved line yet. So we could have a distance time graph. That would be an example of a curved line. The curved line is going to mean the speed is changing. So either that object is speeding up, okay, it's accelerating, or it's going to be slowing down or decelerating. And deceleration, another way we could say that is negative acceleration. Now, kind of a little trick when we're looking at these curved lines to figure whether it's accelerating or not. Okay? So if I have this line over on the side here, it's curved. What I want to do, and it's just a little sketch, we're going to draw tiny little tangent lines. And a tangent line is just a little line that touches the curve in one spot. Okay? That's what you're trying to do. Pretty hard to do with your pencil or with the marker here, but that's what I'm trying to do. If I draw tiny little tangent lines on that graph, I have one here, and let's put one up here. Usually kind of at the beginning and at the end. So when we look at this tangent line is pretty flat. This tangent line is pretty steep. Though the slope of those tangent lines would equal to the speed of the object. So this guy's pretty flat, speed is low. Pretty steep, speed is high. So this object would be speeding up or accelerating. Okay. Let's try another one. Okay. It is a distance time sketch. It is a curved line, meaning my speed is not constant. It's a curved line, that means either I'm accelerating or decelerating. Okay? The object is still going away from home. Okay? Start position is here, and at the end, its position is further away. So it's going away from home. Now let's draw those little tangent lines in. So one here, and one here. Kind of a flat line that's supposed to only hit the graph in one spot. So the slope of this line is steeper than the slope of this line. It's greater slope, a smaller slope. That means its speed is greater here, speed is less at that point. So this object is slowing down. Okay? It's decelerating or negative acceleration. Okay. Okay, so this is what a graph might look like. When we look at these different parts, let's look at the red one first. This is a distance time, and it's really more like a sketch than a graph. Okay? So here the red, this section is a constant speed. I know it's a constant speed because it's a straight line segment. Okay? This is a horizontal line. If it's horizontal line for a distance time sketch, that means it's not moving. It's stationary. This guy, again, it has a straight line, so it's going to be a constant speed, but this object is now going back to home. Okay, so it's going back to home at a constant speed. This guy, the green one, it is going very fast. Why can I say it's going very fast? Because the line is quite steep. And it's also a constant speed. Then we have the blue one here. Blue one, well, we know it's not a constant speed because it's a curve. And we have to decide, is it speeding up or slowing down? So if I have my little tangent lines, This one's pretty flat, so that means its speed is slow or low. This one's pretty steep, so it is faster. So we can say that object is getting faster or it's accelerating. Okay, what can we say here? Number one, what's happening? That object is not moving. It is stationary. It's not at home, okay, because it's not at the origin, but it is still not moving wherever it is. This one, we have two different lines. What could we say about them? Let's put an A and a B here.
A's moving faster than B.
A is going faster than B, exactly. And both A and B have a constant speed because they're straight line segments. Okay, what can we say about this?
It was going fast and then it went stationary.
So we can say that this at the beginning, it's going relatively fast, okay? Its speed is constant. It is moving away from home. And then at this point, it has stopped, okay? It's away from home still, but it's stationary. It's not moving. Here, what do we have going on?
Acceleration and deceleration.
No, here we have the first part is a constant speed, but the object is going away from home. The B is a constant speed because it's a straight line, but the object is moving towards home. And the last one, it is not a straight line, so there is some sort of acceleration going on. Either it's positive or negative acceleration. And again, we can do our little tangent lines, and it's steeper at the end, so this is going to be positive acceleration. Okay. Now we want to kind of look at some stories here and see what story will match our graph. Okay? So as we go through, we'll see if there's a problem with any of the statements. It says, Tom took his dog for a walk to the park. He set off slowly and then increased his pace, meaning he accelerated. Is this showing acceleration? No, because it's a straight line segment. So I can cross off A. The other thing I would have looked at this and said, oh, is this saying slowly? It's a relatively steep line, so I don't know about that. But anyway, A is not the story that goes with it. B, Tom rode his bike east from his home up a steep hill. After a while, the slope eased off, and at the top, he raced down the other side.
No,
Well,
because he went up super fast and it was up a steep slope, so you can't go up that fast.
okay, if you're going a steep slope, you are likely to be going slower, okay? And then it says, after a while, the slope eased off, which means that you would probably be going faster at that point, okay? Here, I am going faster. The slope here is less, so I am going slower at that point. So I'm going to cross off B. Tom went for a jog. At the end of his road, he bumped into a friend, and his pace slowed. Tom left his friend. He walked quickly back home.
Yeah.
So, went for a jog, met up with a friend and slowed down, still constant, and then he went back home. Okay, so C would be the correct one. Okay. so that's the same. Okay. Okay, so we want to be able to sketch on the same set of axes a distance time graph for. And it's really a distance time sketch we're looking at. So I want you to put a set of axes down. And it's distance time. Time is always on the x. So I know t is here and I know d is at that point. A distance time. Okay, don't know if I have all these colors, but I'll give it a try. It says a car moving at a steady speed. Okay, so perhaps I'm looking at this. A car. Whichever way, whatever the slope is you put on that, and it doesn't have to be this slope, but you absolutely have to have a straight line. Because it's saying it's a steady speed or a constant speed. Okay. Then we have blue, which will be my black. A bus moving at a steady speed greater than the car. Okay. What do I have to do? Is it going to be a straight line segment? Yes, because it's a steady speed. It says it is going faster than the car. So that means I have to make it steeper. Exactly. Okay? So long as it's a line that's above your car, again, it doesn't have to be exactly here. It just needs to be a line above your car. Okay, our last one. We have a lorry increasing in speed from rest. Okay, increasing in speed means I cannot have a straight line segment. And so I will draw like that. Something like that. So that it gets a higher slope at the end and a smaller slope of the line at the beginning. Okay, and that is it for today. Now we want to just do some questions. And